Howdy everyone. In this video we're going to dive into the fascinating world of probability and statistics as we explore the inverse transform sampling method to generate random variables from the distribution of the maximum of 1000 uniformly distributed random variable. So as we can see in this tutorial by the way is in my website in the Circuit of Knowledge section. So this tutorial is allowing us to learn how to use and accelerate Monte Carlo simulations by using the inverse transform sampling method, ITS method, sometimes also called inverse sampling. Imagine you have 1,000 random variables, all uniformly distributed between 0 and 1. And rather than generating all these random variables and then searching for the maximum, which is an expensive type of operation, we'll use a clever shortcut that avoids this unnecessary computation. First, let's understand the math behind it. Each of our uniform random variables has a cumulative distribution function, CDF, represented by uppercase F of x that equals x for values from 0 and 1, which is the CDF of a uniformly distributed random variable. The maximum of these, denoted by capital M sub n, has a CDF of x to the n, and we calculate it here in this tutorial. Is any individual random variable has this kind of CDF. To find random values following this maximum distribution, we'll apply the ITS method. This involves generating a standard uniform random variable and then transforming it using the inverse of these maximum CDF that we found. So in this case, it's u to the power of 1 over n, like we see here. Generating many such values allows us to approximate and visualize the distribution of the maximum efficiently and accurately. This method is not only elegant but highly efficient, bypassing the need to directly simulate thousands of random variables and search for the maximum, and is very well preferred for applications needing fast Monte Carlo convergence of extreme values. It doesn't have to be the maximum, it can be the minimum or any other statistic over large random vectors. And here we have a Python code that basically evaluates it and plotting the PDF or the density of the maximum value. So this is the PDF of U1, maximum U1 to UN. And here I do a runtime comparison between actually Monte Carloing it using uniform random vectors and searching for the maximum compared to versus using our ITS method. And we can see that the times here are 158 milliseconds comparing to something that is below the resolution of the numbers that I put on the screen, which is probably microseconds. And we plot the histograms of both methods and we see that the histograms match. Thank you for listening to this very short tutorial. There are more like this type of content in my Circuit of Knowledge section on my website. I hope you will enjoy it. Thank you very much.